Before I go on to present his talk, to play his talk, I'd like to make a short introduction. He's a well-known person within the tech community, a long-time contributor, somebody with a training in chemist, but dozens and dozens of packages developed and dozens of articles on Tugboat and thousands of answers on Stack Exchange, which has helped the tech community tremendously. He's a member of the LaTeX 3 core team, and as such is shaping the way that we'll be using LaTeX in the future. So with you, Joseph Wright, on the release of his update to the package siunitx.
Hello, I'm Joseph Wright, and in this talk I'm going to be looking at siunitx version 3. In particular, I want to look at the history of siunitx and how I've gone about releasing the third major version. This is a talk about a package that I write and I maintain, but there's going to be a lot of LaTeX team code mentioned here, so I'm going to reference up front that this is an expl3 package using a lot of expl3 and related methods. So although the team's contribution here is not direct in the code, it is in the environment in which it's written. So this is really an update for a talk I gave back in 2018 in Rio de Janeiro, and I've taken there a slide from that talk where I told you at that time about what I was doing working toward version 3. And what I told you was that I'd got quite a bit working. I'd got core functionality working for a third version, and I'd got some updates for an existing API, but I'd got lots of to-dos, and those to-dos were a real challenge. So one of the things I want to explain is what I've been able to do in order to address that to-do list. And we're going to come back to a version of that slide toward the end of my talk. But I'm going to take you back now to 2007. So this is how I got into this area, and really how I got into be a serious tech programmer. There was an email from Stefan Pinot to the newsgroup Context Tech in the days where that was where you reported LaTeX bugs. And you'll see that he found a bug in a package called siunitx, and siunitx allowed you to write units in a somewhat semantic way. You'll see some of the macros are a little bit awkward, and to have it format the output in either math mode or in text mode. And he found this bug in the text mode output. And I saw that, and I was interested in units. There was a few packages at the time. siunitx was one of the leading ones, and I spotted this, and I said, oh, I'll come up with a fix. And then it turned out that siunitx was no longer really supported by its author. He'd moved on to other things, and so I ended up sort of volunteering to take over the package. And then I looked at the other Unix packages that were out there, and I made a rather foolish decision, which was to take over both siunits and a related package called sistyle, which did sort of complementary things, and to come up with a single combined package that would do all of the things they did and bring in features from other packages. So I've referenced numprint, units, unitsdef, and hep units, and to try and bring a single consistent interface. And one of the ideas I had was I could do the units parsing better. And in fact, that is going to be the core of siunitx from then to now. So I sat down and I started writing a package. The very first testing version wasn't called siunitx, it was just called si, and you'll see here 18th of February 2008 was when the first release went to CTAN as an experimental pre-version 1 package. It took a little bit longer, till April of 2008, for me to get everything finished. And one of the reasons was it turned out that what a lot of I ended up doing was actually not units or supporting units with simple number formatting, but making tables of numbers. And that a lot of code there was inspired by a package called rccol. Why was that? Well, in order to when you format units, quite often you want to write quantities. A quantity is a number and a unit, and if you want to do that, you want to be able to do various things with a number, And then once you start passing numbers and formatting numbers, then it makes sense to extend to columns of numbers. And so that's, although I would say siunitx was and remains a Unix package, there's quite a bit of the code that's actually about tables. So that first release went quite well. What could it do? It could parse and format units. That was the core idea I'd had that I could bring here that was a new thing. It had a single keyval interface for all of the different functions. So if you look at the predecessors, they tend to use different commands for different parts of what they're doing. I wanted to do better than that. It had automatic number formatting, so I inherited some of that from numprint. I brought a few ideas of my own, including sort of dealing with uncertainties, standard deviations. It could do tabular alignment based on code from RCcol, also based on some code from dcolumn. And that rolled on into 2010, so I got to February 2010. So this is 2 years after the first testing release, and I got to version 1.4c. 1.4c is the last version on the 1.x series. What was wrong with it? Well, the internals were mainly just me recoding stuff from other packages, certainly the ideas, other than the unit parser, which I'd written from scratch. The keyval names, I'd made some mistakes there, and there wasn't really any internal API or any internal documentation. A lot of the loops inside it were self-coded and not very efficient, and I wanted to do better. So I took a step back and I decided on a rewrite. So my initial plan was to rewrite in the same style, classical tech programming, lots of @ symbols. But around this time, Will Robertson had pointed me to Expo3 and asked me about it, and I was looking at it quite heavily, and there were lots of good ideas. So I thought, oh, I'll recode them myself. But as I worked on it, the number of ideas I wanted was so large that I was going to basically duplicate all of that effort, and it was not a sensible plan. So at this point, I decided to say I was going to require Expo3. Now in 2010, that wasn't a straightforward decision. I wouldn't have any worries about it today. Because the language wasn't quite as stable, it wasn't as widespread, there weren't as many features. One of the features there wasn't was a keyval high-level interface. So I wrote one, I suggested it to the team, and they adopted it, and then I was invited to join the LaTeX team. I came up with some newer internal API, so there were some internal structures to version 2, and performance was improved. Part of that was using Expo3 for loops and things rather than my own coding. Part of it was I rethought some ideas. Now that version 2 series went pretty well. So you'll see this is the last identifying line from the 2.x series, and this has got to 2021. Although, as I said, I actually started thinking about problems I'd had in version 2 back in 2014, and I said that out in Brazil. What was wrong with version 2? Well, you know, every time you make a new version, you make new mistakes. So it made some assumptions about fonts. So particularly as we move to a Unicode world, some assumptions about how characters are set up were just wrong. Expo3 has developed a lot in the past 12 years, certainly in terms of best practice in public. I'm sure Frank, David, Chris have ideas, the same fundamental ideas are there, but we've got a better stability of those ideas, clear idea of internal code, documented code level functions, and then document level functions. The internals are still too messy, and that links to it being a monolithic source. So there's rather a lot of code in version 2 where one part of an implementation relies on knowing about another part, just too much of it. The only testing there is the documentation. You touch the documentation, if that works, it's probably okay, and that's not ideal. That document is pretty long, it's getting on for 100 pages, and so finding mistakes problematic. And there's still performance issues. So I wanted to address all of that. And I wanted to address that by first building tests, then writing the code, and so I could actually be sure that version 3 would not have some of the issues I had. So from version 1 to version 2 I made quite a lot of changes, and some of that didn't work so well. So for version 3 I wanted to have a better idea that my launch would go well. One of the biggest changes and one of the blockers for launching version 3, when I talked about this last, was the change of font handling. So what siunitx does is it says, well, the official guidelines for typesetting units are they should be in an upright Roman font, and they shouldn't obey local font changes. So in version 2, that's implemented by detecting the current font, using an mbox, so text, to force us out of math mode, then forcing us back into math mode, and then potentially applying text again if we want to typeset in text mode, and then adding whatever font commands we need to restore whichever local font settings we've been asked to. So you can turn that on and off. And you'll see that doesn't look very efficient. It's quite slow because it always forces change from text to maths and possibly back to text. And it's not always 100% reliable. There are cases that are difficult to pick up. So the new approach is look at the current font settings, and if we need to reset something, we set it. If we don't, we leave it alone. And it means that you only use an mbox if you need to change the math version. Now that's important because it means that if you're in text mode and you're being asked to typeset in text mode, you don't put stuff in a box, and so spaces can be broken out if we want to. So it enables some breaking of things which weren't possible in versions 1 and 2. Now the thing is, you'll see that those are fundamentally different approaches. All the keys have been renamed, and so I was stuck with how was I going to launch, because I knew there'd be people who would run into problems with this. So back to the slide about version 3. So I got the unit formatting. So core functionality, we can parse units, we can format them, we can do real number formatting, we can do tabular columns, and this was all out there in 2018. I've kept the old API, that's capital SI and lowercase si. Those names were never great. Capital SI was inherited from a predecessor package, lowercase si was something that matched it, and it's the one that's used for units. But you'll see that they aren't really semantic. Capital SI is quantities, lowercase si is units. They're not great. The retained document API, so num is fine for numbers, and the S column I've retained, that's for number alignment. Now, I did toy with changing the S column to something else, but there's a very limited number of tokens you can use for column names because of the fact they have to be a single letter. And so I didn't really want to risk taking another letter there. So you might, if you want a more semantic view, want to call that an N column for numerical alignment. And in the version 3 code, you can tell siunitx what to call that column. So I'd be tempted to think about that, but I haven't changed it globally. Then I've got a new API. Now this is now no longer experimental, this is the new approach. So /unit. Why didn't I use that in version 1 and 2? Well, the units package uses unit in a different way, but well, in versions 1 and 2 I wanted to let you load both. For version 3, tough. Load one or the other. And qty for quantity. Now that clashes with the physics package. But again, I've decided I'm going to accept that clash. If the physics package is loaded, I don't define qty, I only define uppercase SI. The physics package has got various problems, and I have decided that, you know, I will live with that clash. Also working now, compatibility settings. So I've written a reasonable amount of compatibility code, but as I said, there are places that you can't be compatible. How did I fix that? Well, the LaTeX team, since 2018, came up with a way of rolling back packages. So there, the idea is if you have a distribution where you have an old version of a package and you name it in the right way and you set up a couple of lines in your new package, the user can say in their document, use package, name of package, optional argument, identifier for the old version, and it will load. So that means that if people need version 2, they get version 2.8e, the very last release. The only changes that will ever be made to that code now are if I need to maintain compatibility with Expo 3, but that is frozen, and so you can force a frozen usage. Products, range and lists I've now sorted out, and the way I sorted those out is I realised that what I want to do is I want to keep num, unit and quantity fast. So they're focused on a single, num and quantity are focused on a single number. A product is something like 4 meters by 3 meters, and that's not a single number. A range is 2 meters to 4 meters, and a list is 2, 3 or 4 meters. They're all semantically different from a single number, and because they're relatively rarely used, I can afford to have them use a slower parsing to pull out that information. I did something similar with complex numbers, which used to be covered as part of /num, but now they have their own document level API, complex num, complex qty. The reason is there. that again, I've got a new internal format for numbers, and it's for real numbers. And it's very efficient, it's faster. But it doesn't cover complex numbers, which are essentially two real numbers put together, one of which is the complex part, the real version of the complex part. Now it does mean I've changed the semantics of num, but it also means that I gain performance for the very common case of real numbers only. It also means there are various bugs in version 2 that most people haven't noticed because they haven't pushed combining complex numbers, products and ranges and lists. If you try to, you get some odd results. Now I've divided things up, you don't. I've got evaluation of expressions that's a sort of a natural extension of using expl3 having developed the FPU. It means that you can put in an expression inside your number rather than the number itself, and it will be evaluated now. Got multi-part uncertainties. People have wanted this for a long time. So in versions 1 and 2, I used a single symmetrical uncertainty, an ESD as I'd call it from my background. But there are areas that use multiple uncertainties. A lot of physics uses different types of uncertainty. You might have a systematic uncertainty and a statistical uncertainty. And siunitx 3.1 can handle those. And my internal number format, which is now documented in the API for code level work, has a clear path to get to asymmetric uncertainties. It can handle storing them. I know how to present them. That will be in version 3.2, I suspect around the end of 2022. Looking a little bit further, I know that people would like to be able to pass free-form units, and I have plans on how to do that. So what I want to do now is just think a little bit about the tools that got me to actually being able to release version 3, which was out about a year ago. So expl3 has been vital in both version 2 and version 3, and the improvements in expl3 over the past decade have really driven me to write better code in siunitx. So I would say that siunitx is now an exemplar package of how to write a large expl3 based package. LT command, what used to be called XPath, has delivered the ability to come up with new APIs very easily, and that nice clean separation of layers has come about as part of that. I've emphasized L3 build here because it more than anything has delivered. All of the tests I've written, which are taken those old PDF based tests and written them out as clear traceable tests in a text format, they're all in L3 build. They are vital because they mean that I now, when I make a change, I can do that development work and I know I won't be breaking stuff, or I know what will change. It's a lot more comfortable for me. I'm going to reference GitHub Actions there. So GitHub obviously is a commercial situation, but Actions works very well. I used to use a previous CI. There are others out there, but I would say if you're writing a large-scale LaTeX package, automate your testing because it doesn't get bored. It runs every time I make a commit. I'm also going to reference something else commercial, Git Kraken. That's the Git GUI I use. I use some of the more advanced features for other LaTeX work, but for siunitx I just want simple interface and it lets me keep a track of where I'm up to. I like it very much. I also like something which is free and funded by TUG, TechWorks. TechWorks was written as an interface for an editor for beginners, but I think it is a brilliant editor for doing lots of work. It does occasionally run out of steam and I have to use something else, a programmer's editor for complex operations, but my day-to-day tech programming and as a user is all TechWorks. I want to finish with some thanks. I have to thank Stefan Pinot. He got me into this, and Stefan contributed an awful lot of beta testing in versions 1 and 2. The predecessor packages were written by Danny Els, Marcel Heldorn, Harold Harders, and Erkehard Guthochholm. All important code. Frank Mittelbach, obviously lead of the LaTeX team, but here I had some very useful discussions about the font detection system and how to improve it for version 3. David Carlisle famously wrote D-column, and siunitx implements the D-column strategy as well as the RC-column strategy. Will has been very useful in talking about how to deal with special symbols, particularly the open type math setup. Till Tantau wrote PGF keys, which I based L3 keys on, and I think that's vitally important for how siunitx works. And finally, my guru for math mode is Enrico Gregorio, E. Greg as